We're going to go ahead and get started with API 201, bringing healthcare APIs to life. I'm going to cover two quick housekeeping items, and then we'll move through introductions and to today's content. So first, today's webinar is live and it is being recorded. Everyone who has registered will receive a copy of the recording. Throughout, everyone will be muted, but we do want this to be interactive. So if you have questions, please drop them in the questions panel, and we'll answer them at the end or follow up if needed. So we'll spend the next 45 minutes talking about all things APIs, following up from our API 101 webinar in October. If you missed that webinar or want a refresher on APIs in general, I highly recommend watching that recording, which is available on the Rhapsody website. Today, we'll focus on unlocking more value with APIs by discussing two real-world API workflows, and we'll share practical guidance on leveraging APIs in your day-to-day. So my name is Deb Daly, and I lead product marketing here at Rhapsody. And you'll primarily be hearing from Marshall and Dan, our resident experts today. So Marshall and Dan, if you could just jump in and give a quick introduction, that would be great.
Yeah, for sure. Marshall Peterson, I'm a Principal Technical Product Manager here at Rhapsody over our API strategy and API products. So looking forward to speaking with everybody today.
And I'm Dan Sabo with our professional services group, just kind of an on-the-ground engine interface builder like most of you.
Awesome, thank you both. So I'm going to kick us off with a quick overview and refresher on APIs in general. So in plain language, APIs define how two systems exchange data. And from a technical standpoint, APIs spell out the rules for communication. So what data can be exchanged, how authentication works, and what actions are allowed. And APIs are really critical for the future of healthcare interoperability because they're human readable, which is a bit different from HL7, where you need to know, for example, what a PID3 segment is to understand the message. And they allow for real-time data exchange back and forth between two systems. That extensibility and the real-time nature of APIs is what can help us unlock more efficiencies and have more effective data exchange. So three use cases that we talked about on the last webinar are prior authorization, where APIs can transform those prior auth checks from manual phone calls back and forth to real-time automated checks between payer and provider systems. Public health agencies can leverage APIs and bulk FHIR to automate real-time data sharing instead of weekly or manual manual data pulls monthly or weekly. And then last but not least, FHIR facades, which we'll talk much more about in today's session, enable exchanging data via FHIR without needing a FHIR server. And so with that refresher out of the way, we're going to dig into two practical use cases, like I mentioned. So first, Dan is going to talk to us about a reporting use case, and then Marshall is going to talk about FHIR facades as well. So we're going to go ahead and switch over to reporting.
All right, let me get my screen shared here. All right. Before I jump into my slides, wanted to just talk a little bit about what I would hope folks will get from my section. The primary thing is an example. We've seen a lot more activity with our customers building APIs, but they tend to be calling other people's APIs, and so not as much hosting an API in our engines. So having that example, we think will be a great help, and not just from the aspect of the technical side of seeing it, but also kind of getting ourselves into the mind frame of when is a hosted API in our engine useful? When should we be on the lookout for opportunities? So there's kind of two aspects that we think will be useful, and I think as we go through this and as you see this one example, we want you to have that open mind and open ears and eyes for future opportunities for hosted APIs. So real quick, I'm going to throw up a couple diagrams of interface types here. This is our old humble messaging interface, typically HL7. The reason I'm throwing this up here is to point out that one thing we typically do not do with these interfaces is a lot of validation. We may check for required fields and act on that occasionally, but for the most part, we are accepting the message. Once this is an established interface, we're focused on this transformation before we send it out. We're not typically too involved in the response that we send back to the partner. Our engines are good at automating that part, and we don't typically worry about that in this type of interface. Now, kind of a reporting interface that maybe you have come across. The way that this has been presented to me many times, or an ask that I've had to carry out, is someone realizes that the engine is in the middle of data, has access to data that they are looking for, and makes a request for a certain collation or format of that output. And typically they would like it on a certain interval. So an example would be they want an email in their inbox every morning with some kind of summary, or they want a CSV file put on a file system once a week. So just this is showing that the data sources that we are gathering the information from could vary. Sometimes it's a file, more typically a database, and this is just showing that we may actually be calling another API here. This is what some of our other webinars and sessions have been about, is calling an API for retrieving data. That could in fact be part of what we're doing here for a reporting interface. So we've got a timer, this triggers it, we're retrieving, we're formatting, and we're outputting it in whatever the desired form was. This is an example of reporting where we're really just getting information and presenting to this consumer. An example, this is a cute little HTML table that someone wanted in their inbox with a summary, a sort of a rolling 7 days of the totals of special procedures that were being performed, and then one that had the total count for an entire range. So if you think about producing this reporting interface, great, it's exactly what they wanted. Let's say someone else then makes a request that they want more information in this table, or they want it at a different frequency and more recipients. These are all things that we would be visiting this existing interface. Are we going to make a new one? Are we going to change the existing one? Do we now have 2 reporting interfaces? These are the things that we're going to hope that after today kind of trigger this thought. Could this be an opportunity for a hosted API in my engine? Because those things are fixed in this type of interface. So as we talk about hosting an API in your engine, just some points to consider. Again, your engine is in general in the middle of a lot of data. So and hopefully people in your facility are aware of that. And when they are, they can come to you with requests for consolidating that data. So just the access to the data sources, this is an ideal place to be thinking about hosting an API. Unified and normalized data, just thinking there about, again, this idea where we might have more than one. If we go back to our last diagram, we might be getting a record from a database and then calling an API and consolidating both of those data streams for our API. And normalized, if we make our engine API the thing that people call whenever they want this data, our entire enterprise is dealing with the same format and the same type of data, which is an advantage. On demand, we saw this idea of having it on a timer with our standard reporting interface. With a REST API, consumers can call it at any time, so big advantage there. Enable system-to-system integration. when we are talking about two applications trying to share data, we no longer want to be in the game of dropping a CSV file on a shared file system that someone else picks up, right? A REST API is the way that applications want to talk to each other these days. Scales easily. Once we have our endpoint up, it doesn't matter how many consumers are going to hit it, we're ready for it. And flexible and extensible. As we build an API, I think you'll see in my section here, we're going to be thinking about making it multifunction. We're going to be thinking about making it flexible so that it has more use for more consumers. And extensible, there are kind of best practices when we build APIs that allow us to add on without breaking existing functionality. And that's something I didn't really cover today, but we can talk about it if I have a little time at the end. So hosted API, here's how I wanted to represent it on a diagram. We have our data sources, the same ones we were talking about before. We're going to have a consumer that sends us a request. In this case, we're focusing on a reporting interface. So the request will be a request for data, not transferring data to us, right? So this will be a request to retrieve data, and we will be sending a response back to the consumer. But what are we doing here in our engine? Kind of some newer concepts if you haven't done a hosted API before. We talked about not needing to validate in other types of interfaces. Here we are validating this request coming in, not only from the standpoint of is it a good request versus a bad request, but if we're offering multiple routes, multiple actions, different functionality on this single endpoint, we need to know which request was made. And that request determines potentially how our retrieve is done. That may be different depending on what the call was. How we process and format the data, potentially different for each call, and what our response is and what the body of that response will be changes potentially with each call. So if we have this generic get data call, and our response might look something like this. If we then add we add support for a P1 parameter, maybe and someone makes that call, the data might look a little bit different. And we also have to accommodate bad requests of any kind, right? And we're going to have a potentially different response for those. So this is kind of we generally want to do this all in one place in our request handler. It's kind of a newer concept, I think, if you haven't done a request handler before, and that's kind of what we want to touch on today. So let's get into our example of bed census reporting. This really is just an example. We wanted it to be real world, and I've done a little bit of research. But so regardless of where this actually fits in the world of being useful with all the existing solutions out there, I still think it's a valid example. But just to touch on the real world possibilities, these are some parts of an operation that might be interested in consuming bed census data. So some of these would maybe just be interested in a current snapshot. Anything that needed to know capacity management might be just what is the state now. Some others are resource planning, business intelligence, maybe need the idea of a historic or a snapshot from a different time. Workflow automation, now we maybe get into some kind of triggering where we detect a certain state, and then it's kind of a service management aspect. Maybe if you have a ServiceNow or some other dashboard, maybe this data could be used to be displayed there, or even trigger some kind of alert or notification. So what integration opportunities do we have given what is out there? And again, with not too much research, it seems to me a lot of this functionality right now is kind of built into the EMR, not maybe accessible to if there are consumers outside of the applications that are not part of the EMR that need this data. I don't think I've seen that many of the common EMRs have an API at all. So even just having an API that exposes the simplest, most basic bed census data could be useful for some of these consumers. Again, we talked a little bit about here, if we added the ability to do historic data, that's going to make it more useful for consumers doing some analysis. And if we could get to the point where it sort of automates the idea of detecting a change in state, something like, you know, bed turning over where we need to clean the room, right? That kind of use case could gain use from our API. This is the data. So the data, I'm not going to focus on too much because for everyone's scenario, this might be different. The way this one was built, this is the data that the API, that the engine has access to. And just to orient ourselves, each row is a bed and its status at a given snapshot, a given point in time. And that snapshot timestamp is here in the far left. So we could see the first 14 rows are all this 8 a.m. snapshot, and they're all in the 14 beds that are in our facility. So we have 8 beds in our 4W unit and 6 beds in our ICU unit. And then we have another snapshot starting down here. So we can think of this as existing in a database that this is our data source for our API and our engine. So these next 2 slides are going to be kind of a time lapse where I'm hoping to show how this development of this API might progress. If we were just to offer the basic bed census, get bed census endpoint, all it's doing is return data from our most recent snapshot. This might be our first shot at what our payload looks like in our response. So JSON, an array of items, and really the items are just all the columns that we had in our table there, except for the timestamp. And so the timestamp applies to all of them. Kind of our first evolution, I think, of our data. We could be considered here. Add the timestamp that we retrieved it from. That applies to the entire payload. And conventional thing to add in REST APIs, give them a count. So this is our first evolution. We end up with a count and then our items. So if we think about this was the basic functionality that some of the consumers could potentially get use from. We think about, and certainly they could then do work on their side after retrieving it. Maybe they're going to record the snapshots. Maybe they're going to try and do filtering or something. But we think about now adding functionality to our endpoint because it could then be more useful for different consumers. So maybe our next step is to add this @ parameter. It's a timestamp, and now given that target date time, we will return the data from the nearest prior snapshot. So we've now built into it the ability to serve up historic data. And again, we saw some of the consumers would, I think, find that useful to do analytics. All we've added here, the bottom is all the same and the snapshot at the top is the same. All we've added here is this requested section. This is, since we're now supporting parameters, we're going to mirror back those parameters. We'll talk a little bit later about what this source is, but you can see it's the @ parameter had this value when it was passed in. Okay, let's say we're getting more ambitious, more interested in getting use out of this thing. So we add another parameter, the unit filter. So this is the same thing as before, only we can filter by unit. And all this is showing is that there we see our unit parameter mirrored back in the requested section. Now our count is down to 6, right? So we only have 6 ICU beds. That's reflected here. These are all, of course, partial JSON. They're all chopped off. I wanted to make them large enough for it to read. Now we're going to talk about the diff a little bit. Let's say we are interested in giving that the extra bit of functionality to allow a diff between two snapshots. So here our resource path has changed. It's no longer just get bet census, it's /diff. We have a from and a to parameter. They're both timestamps. Here's an example. What do we do with this guy? This guy is, we're comparing two snapshots. The thing that we are comparing, the item, is really a bed, which is defined by the combination of unit, room, and bed. And we're going to offer these different groups in our payload, so added, removed, and changed. So this is all the same payload, just split to make it large enough. This is entirely different now from our regular bed census endpoint, right? The JSON is a totally different format. So from to, these are our snapshots from the database that we retrieved from. Here's our requested parameters. Here's a summary section showing added, removed, changed counts. And then over here, it continues, we have the changed array with our key being unit, room, bed, and then all the values from the from and all the values from the to. So we can see, well, we're telling the consumer that something about this key or this bed has changed. We will leave it up to the consumer to determine what. We're just giving them all the data from both. So a little more functionality there. Now let's cover some of these error cases, right? We again, in our request handler, we're needing to accommodate all of this. So a bad request, in this case, it was someone somehow sent a timestamp with the 13th month. So that's invalid. It's a 400. Notice this error schema is going to be the same for all of our errors, but we won't populate all the fields for all the different error types. So this one is telling us that it's got a detailed section with the parameter that was at fault here and what the issue was. We also still include the requested and a couple other items here telling reflecting the call, the path, and the timestamp of the call. Here we have a case where the call was just back too far, right? We don't have data from 2024, so it's a valid request. However, the snapshot was not found, so we have an appropriate response with the 404 for not found and an appropriate message. So we have and mirroring back the things that they sent. One more, this was again calling something that we don't even support, right? This resource path is not supported. So we're gonna, it is a 404 again, but is gonna be unexpected resource path not found. So as we saw there, we sort of added more functionality to our API, which I think enables, if we think about what the client would need to do, certainly the clients can do more work on their side with the basic endpoint, but as we added more functionality to both the calls that we support and the JSON that we return, it becomes more useful and potentially more consumers can get use from it. This is just a snapshot of I built this API, by the way, in CorePoint, and that was a snapshot of the action list, the request handling action list. But for now, I'm going to switch over and just kind of do a demo to show it working. So on the right here, I have a Postman, an instance of Postman, which, if you haven't used it, is an application that allows you to test an API. So I've configured in here. This is simulating a consumer or a client that is requesting data of my bed census endpoint. On the left here is my CorePoint monitor with my bed census connection showing here. So if I'll just do a couple calls here, maybe 3, I have because we've seen output from most of them, but so the basic bed census endpoint, if I make that call, I get a 200 response. There I see my request came in and my response went back in my monitor. This is my 14. I get all 14 of my beds. And here's what I wanted to show. In this case, we did not send an at parameter, but this was the purpose of this source. We're basically, we have an implied parameter that they didn't send it, but we're going to mirror back that it was a defaulted at parameter with the timestamp of now. This is, everything's a UTC for this, so this was the timestamp 1928, corresponds to my time. Let's do we can do a unit. This was just the unit filter. So this is the one where I make this request, got the 200 okay, and we've got the count of 6, right? So instead of all 14, we had 6. Notice here, we made a choice that when, kind of a best practice for JSON, when the fields are empty, we don't include them at all. So when it's a vacant room, for instance, it won't have things like MRN or attending provider. They're just not included. And then that's different if we go over to the, let's go to the diff. You may have seen from the JSON, this is a diff with an ICU filter. So we have the from, the to, and the IC and the filter. This one, so there were only 2 changed in this. We made the choice that unlike the normal convention, when these are not present, we would still include them all so that we kind of have a 1-to-1. So these would just be null, even though in the other response we made them, we omitted them. I think that made more sense from a comparison standpoint. So there's kind of the postman end of things. We saw the responses coming back here. If we look at the core point end, we saw these all arriving with our little statistic there. If I just double click and open those logs, we can look at our responses here. So there's our 14 count. So all that stuff's there. Here's our ICU filter 6. And here was our response for the diff, which we saw some of. And if you get ambitious and this becomes an API that really gets traction in your organization, something that you can think about is, I have up here the open API documentation. So I was able to work this up for my little bed census here, including things like my parameters that are supported, including an example. This is all pretty cool. I mean, if you guys are used to building APIs, you will be used to this type of documentation. You really need almost nothing else. It really kind of very thorough. So example values, and then even example responses for 200, 400, 404, and down here is my diff. And notice here it's telling us that these are required examples here, required parameters, and more of the example responses. So that's a kind of a nice to have. That was really what I had. I'm going to switch back to so that Deb can be presenter.
Awesome, thank you, Dan.
Okay.
And next, we're going to jump into fire facades, like I said. So Marshall, if you can take it from here.
Yeah, for sure. So what Dane described is a single use case that can be accomplished through the creation of an API, and that's what we really want to show in this webinar are some of the patterns that you can use to design your own APIs. And I get asked a lot, what are some specific use cases? Well, the use cases are endless. What's more important is that you understand the different patterns that you can use to create your APIs, and kind of the use cases themselves follow patterns. One of those is a fire facade. Just to a little bit of clarification, you're going to hear 3 terms as you become more and more, you kind of go deeper into your fire integration journey. And you're going to hear fire wrapper, you're going to hear fire proxy, and you'll hear fire facade. And they mean different things. And unfortunately, they mean different things to different people. We're going to box wrapper and proxy up kind of together at a high level to oversimplify. But a wrapper or a proxy, when it comes to Fire, is something that you put in front of an actual Fire server to do like routing. So if you have multi-tenancy and you have to route to different Fire servers, if you need to do transformations or business validation, things coming in, you have specific validation on top of just regular Fire validation, adding and removing data, converting between Fire profiles. Those are wrappers and proxies that that's something you can put in front of an actual Fire server. What we're going to talk about today is a Fire facade. And a Fire facade is kind of a translation layer that where you stand up an API endpoint, an actual Fire API endpoint. So it looks like a normal Fire endpoint. It'll be /Fire/patient or diagnostic report, whatever Fire resource you're making the Fire facade for. And then you're connecting that to a backend system that isn't really a Fire server. It's not storing things in Fire, and it allows you to make like legacy systems accessible to organizations that need to work with Fire. Deb, if you can go to the next slide. So in a Fire facade, you would stand up an API just like Dan had with the bed census. So you would set up something like a Fire patient endpoint. You would give the consumer the ability to access that through the appropriate authentication authorization. That when they called that system, if they did, for instance, if you set up a Fire patient API and allowed the get method, you'd allow them to be able to search for patients inside of your system using the same Fire query parameters that you would use in a normal Fire server. The only difference is it would go to your backend system, whether it's a relational database, whatever backend system that you have access to that has your data. In Dan's example, it was actually a CSV that we were pulling from. You'd pull the appropriate data fields, translate that to an actual Fire patient resource, and then respond with that. So using the same kind of patterns that you saw Dan use, and he did that in CorePoint, it can also be done in our Rhapsody integration engine as well. Using those same patterns, adding the endpoint, the API endpoint for the Fire resource, adding the method that you want, whether it's a post, a get, delete, update, so a put or a patch, and then adding any query parameters you want them to be able to search for. You could actually have allow someone to integrate with you using Fire without having an actual Fire server. Now, Fire servers Fire facades are not inherently good or bad, but they do have purposes, and Fire servers also have a purpose. And so you need to make sure if you're going to use a Fire facade that you know the pros and cons of when to use it, when not to use it. Some use cases is to get up and running with Fire quickly without a Fire server, or if you have something where someone needs to connect for a single purpose, you could create a Fire facade for a resource or two. For meeting specific use cases, a regulatory requirement or a certain app wants to connect to you, you could create a Fire facade to meet those needs. So you just want to make sure as you're deciding when to do a Fire facade that you're doing it clear, you're making that decision wisely, but it can be done. Next slide. So more important than the actual use cases we talked about today, the bed census use case is really cool. Fire facades, that's where my background is Fire, so always excited about that. But more important than those use cases are the patterns of those use cases. So things like retrieving a current snapshot of something. You have data, someone needs a current snapshot of some data in your backend system. You can stand up an API for those to give people access to that data as needed. To retrieve a report over time, you have a set of data, and over a certain amount of time, you need a snapshot of that data over a certain period, rather than just give me that snapshot of like a clinical record as it stands now. The diff of data, which you saw in the bed census, like what's the difference between yesterday and today? If someone needed to know that, you could stand up an API that actually does that for them. They hit the API endpoint to discover your data. You actually return to them the diff between the data. Parameterized queries. This is extremely powerful. So something like a patient endpoint, you could add parameters. You saw the date parameters for the bed census API. But things like a patient facade for fire, you could have first given name and family name, birthday, date of birth, things like that. Queries allow you to target and give people access to data in a targeted fashion. It gives you, when you need to abstract away from complex data sources, so things like HL7, DICOM, or spreadsheets, you could actually abstract away from those, turn them into JSON, which is easily consumable by an end user, and make that data available via an API. The other one is triggering an API workflow. And this becomes important also in like agentic AI work systems, where you want to allow an agent to trigger a workflow. So think of like patient intake. You know, a patient come in as a register, an API is provided, and when that API is called, it triggers a series of actions. So it's triggering a workflow downstream. So more important than the actual use cases are those patterns. And what's been fun is talking to our customers on calls. When we get them to kind of see these patterns, they start to come up with their own use cases on the calls as we talk about APIs. So it's a pretty fun thing to see as people get more familiar with the actual patterns of these use cases. Next slide, please. So APIs are critical for implementing AI. AI is here to stay. It's going to become more and more prominent, especially in integrations and interop. We'll be asked to connect to agentic workflows, and APIs will become more and more important to those systems. If you think about it, we're going to do this at a high level. Two kind of groups of APIs. So you have data APIs, and this will give AI. We're going to use the term agents for right now. Give agents, AI, the information required for actions. So things like a patient resource will give access to the patient demographics. Things like the bed census would give AI access to the information it needs to make decisions about where to put a patient, for instance, because it has the access to the bed census. So you have these data APIs that will give agents information required for actions, and then you have workflow trigger APIs, which would allow an agent to then trigger a workflow. The other thing that APIs will do is provide boundaries for those agents. And because AI is probabilistic in nature, we want to add some deterministic rules and coding around that. And APIs are one of the ways that will be done. Because instead of giving an AI access to all of your database, you can give it access to specific API endpoints and then scope those endpoints to where they can only have access to specific data or query parameters or methods inside of that on that API. So it's a way to put guardrails. The other thing that it will do is as you protect your data using APIs, as agents call those APIs, just as a normal client will call, that it will enforce authorization and authentication, as well as all of the auditing. So you'll be able to see which agent is accessing which data. So you can see as we move into the AI world that APIs become critical to help enable those workflows moving forward. Deb?
Yep. Marshall, I don't know if we lost you, but also looking at time, we'll jump to the end here. So wanted to quickly, give a quick overview of two new solutions or a new solution that Rhapsody's recently released, Rhapsody API Guardian, which is an API gateway to help kind of secure those APIs as you're sharing them externally and exposing them externally. As you heard throughout the webinar, both Marshall and Dan are sort of our resident API experts, among others, and so we're always excited and willing to, have strategy sessions and work through any problems that you all are looking to solve as you sort of advance your API strategy here. So as a follow-on to this webinar, please reach out to us at hello@rhapsody.health to book a one-on-one strategy session. And we are also willing and able to share that file that Dan shared with his action list, as well as the equivalent for Rhapsody as well. So if that's something you'd be interested in, please reach out to us again at hello@rhapsody.health. And in future sessions, we'll continue to dive deeper into APIs and including the AI thread as well. So we hope you join us for future sessions, and we hope this was valuable as you kind of continue your journey with APIs. Thank you, everyone.